R.3, so this is still R.3. This is the other skill I was saying I wanted to go a little bit deeper on, because in class I only select one example per skill, and because it's kind of scrunched up and a lot of information is squeezed into one single section. This stuff can carry on for quite a long time, and I don't really want it to. So, but we do find ourselves needing some more examples. So what I'm going to do is I'm going to go over some more division ones. So R.3, this is the section on polynomials, the arithmetic of polynomials, adding, subtracting, multiplying, dividing. So here we're on division. So I wanted to give you a couple more division problems. We saw one in class, and that might not be enough for everybody. I'm pretty sure that's not going to be enough. So we'll be going over two more problems that are like it. So for this one, example 10 from the actual textbook. So if you actually look up the textbook, if you get one from the library or if you find the PDF online, which I will be posting pieces of the PDF online, by the way, within each material portion. So I'll be going back and checking to see if I put those up. I don't think I did. But they'll be up there. The textbook pages will be on there in PDF format. So this one's the example 10 from the actual textbook. So this is not the one I'm writing. This is the one that is provided with the textbook teacher edition. So let's see, example 10, we're going to divide that polynomial by this other polynomial. So this is what I said in class was the dividend. This is the divisor, the one that is doing the dividing. So that's what we're dividing by. So the way you set it up is it's divisor on the outside, dividend on the inside. The result is the quotient on top, and you get, after a bunch of math, the remainder. So we'll set it up. 3n plus 2 on the outside, and then we check the dividend. Does the dividend have any missing terms? And by missing terms, we're talking about powers on n. It starts with an n cubed, the next term is n squared, then it's n to the first power, then it's no n. There's nothing missing. So by something missing, if I look at the next example, we have an x to the fourth, and it skips straight to an x squared. There's a missing x cubed. That's not the case for this example, though. This one has nothing missing, so everything's there. 12n cubed, or n to the third power, plus 11n squared, plus 5n minus 8 is how we set this up. Okay, so then in class, what we did was we thought in terms of multiplication, going backwards, and you compare leading terms. So the term with the largest degree. In this case, on the outside for the divisor, leading term for the divisor is 3n. Leading term for the dividend is 12n cubed. Make sure you write them in order, what we call standard form, in descending order. So we compare those two terms. Out of a 3n, how do I make a 12n cubed? By multiplication. So what am I multiplying 3n by to turn it into 12n cubed? So it's multiplication but backwards. So 3 became a 12. That's multiplication by 4. N became an n cubed, so I need an extra 2 because we're adding. So when you're trying to multiply or divide exponential expressions, the exponents add or subtract. So what do I add to the 1 that's already there to get 3? It would be 2, is how we figure that one out. So that's going to be 4n squared, and that's going to be written in the top where the quotient goes. So that's the leading term of the quotient. Then we multiply the way we normally would by distributing. 4n squared gets distributed into both of those. So 4n squared times 3n is supposed to be 12n cubed. If you didn't get 12n cubed in the end, you're not doing this right. So then 4n squared also gets multiplied into 2, so that's plus 8n squared. And I've run out of terms in the divisor, so there's nothing else to distribute into. That's what I'm going to check against. So this is basically it's like an approximation. I'm trying to figure out what I'm supposed to get piece by piece. This is what I currently have for the first piece. So you subtract everything. The entire polynomial gets subtracted from the dividend. So then these terms, by design, should cancel out. Then we have to check and carefully check the next two. They're nice and lined up, n squared versus n squared. We have 11n squared, and now it's minus, you distribute the negative, minus n squared. So 11 minus 8n squared, that's going to be positive 3n squared. Then you drop down anything else that remains, plus 5n, and then minus 8. So then once we have a completely simplified subtraction with everything dropped down, this is our new dividend. And we repeat the process all over again as long as the degree of the dividend is no smaller than the degree of the divisor. As soon as the dividend becomes smaller in degree, then we stop. So 3n squared from a 3n, we compare those first terms, the leading terms. 3n becomes a 3n squared if I multiply simply by n. So then you take that n and you're going to distribute into both of those terms. So it's a positive n times 3n squared, positive n and 2 plus 2n. Then you repeat the process, the next step in the procedure, by subtracting the entire resulting product of the new term and the divisor, and you subtract that from the new dividend. So then these are supposed to cancel out, 3n squared minus 3n squared. That negative, though, must also get distributed into the positive 2n, making it a negative 2n. 5n minus 2n is 3n. Drop down the minus 8. That's the new dividend again. And then we repeat this process all over again. 3n versus 3n. They're identical. So how do I go from this one to this one by multiplication? What do I multiply so that way the first thing doesn't change? That would be a 1. So I'm going to say plus 1. 1 times 3n is still 3n. So that's 3n. Distributing the plus 1 would be plus 2. So because we're multiplying this whole thing by 1, it should match on the bottom, and we're going to subtract it. So then when we subtract, 3n's cancel. Negative 8 minus 2 is a negative 10, it looks like. And since negative 10 is a degree 0, this is a degree 1 divisor. This is now smaller in degree than the divisor. We're done with the long division stuff. So all I got to do now is format the answer so that way it makes sense. So this is the remainder. This is the quotient. And the final answer will always be written as the quotient plus the remainder divided by the divisor. So if I do that properly, the quotient is everything in the top, 4n squared plus n plus 1. And then that's a negative 10. So if I'm adding a negative 10, it's going to be the same thing as minus 10 over the divisor, 3n plus 2. So what I did was I took the negative that should be on the top, and I moved it on the outside as a minus. Same idea. So there's how we carry out the long division procedure. It's a lot of work, it's very tedious, but it should be very simple because it just requires multiplication knowledge. So multiplying polynomials to make other polynomials, if you master the multiplication stuff, division's easy, but it's also annoying because it's tedious and there's quite a bit of steps. It's also annoying in another way that there's a bunch of room for mistakes. If you mess up a sign somewhere, the whole thing is going to end up being wrong. So you got to be really careful, double check all your work. And for somebody like me, where arithmetic is not something I'm able to do early in the morning, or actually any time throughout the day, I grew up with calculators. So I'm old, but I'm young enough to where like I was brought up in math courses with calculators. So arithmetic is something that's a little tough for me, even though I am a math person, math teacher with math degrees. But either way, so you want to make sure you're double checking your work. And if you have a calculator on the side, it's probably even better just to verify that you're doing this correctly. So example number 11. This one we actually saw in class. There was a bit of a typo in my thing. So I don't know if we exactly divided by x squared plus 2. I might have just made up another binomial. So because we already used this polynomial, I'm going to swap out this problem for another problem. So I looked up the textbook to see if I can find something that's similar. So I'm going to go ahead and replace that with the similar one. So divide 3x cubed minus, so that's a 3 by the way, 3x cubed minus 2x squared minus 150. And that's going to be divided by x squared minus 4. So I took that out of the textbook, found a similar one. It won't be one of your homework problems. I took it out of the actual textbook pages before the homework. So they always have extra examples in the teacher's edition. So 3x cubed minus 2x squared minus 150, that's getting divided by x squared minus 4. So the reason being is because I've already used this problem in the lecture notes during class synchronously. So you set it up all the same. The one that we're dividing into is the dividend, goes underneath the division symbol. 3x cubed minus 2x squared minus 150. That's going to get divided by. Oh, and there's one other thing. In class, if you remember, this one has missing terms. This one goes from x cubed down to x squared just fine, but then the next one logically should be x with nothing on it. So there should be an x term, and then negative 150, the constant term with no x. So we have a missing x term. So what I would advise then is writing a plus 0x in its place, and then minus 150. It makes the simplification process a lot easier if you write in the missing term with the 0 as a coefficient in front. And then we're going to divide by x squared minus 4. So then we start by comparing leading terms, x squared and 3x cubed. How do I make an x squared, or how do I make a 3x cubed out of an x squared by multiplication? Well, there's a missing 3. So if I multiply 3 and x squared, you get 3x squared. But I want 3x cubed, so I need an extra x to make that 2 into a 3, or to turn the 2 into a 3. So what we do is we distribute that 3x into the second term in that binomial on the outside, 3x times negative 4. So first off, 3x cubed, and then it's going to be negative 12x, it looks like. And here's the thing. We're skipping an x squared term. There's a missing x squared term there. So that negative 12x, I'm going to move over here underneath the 0x to match the degree. So there's basically a missing, so plus 0x squared. There's a missing x squared term, which you don't have to write it, not a big deal. But I wrote it as a 0x. So because this one had a missing x term, so that it went from x squared all the way down to negative 4 without an x term. So then we compare. These get canceled out. These two, negative 2 and then minus 0, will remain in negative 2, x squared. And then we have the 0 minus minus 12. So that's 0 plus 12. So that's positive 12x. And then we drop down the negative 150. That one's along for the ride, has nothing to combine with so far. And that's what we currently have at the moment. So negative 2x squared plus 12x minus 150. So then we start this all over again. We look at the leading terms, negative 2x squared versus x squared. There's a missing negative 2. So if I multiply the negative 2 into the x squared, you get negative 2x squared, which is exactly what I want to cancel out. Then we also carry out the distribution procedure. Negative 2 into negative 4 gives me positive 8. And that positive 8 I'll have to move it all the way over there. So that way it's combinable with the negative 150 because it's not an x term. Then we subtract these. These will cancel. And then the negative 150 minus 8 is negative 158. And we're done with the long division process. Now all I got to do is clean it up and write it in the final form. So then the final form would be quotient. Quotient is 3x minus 2 plus the remainder, which is negative 158. So I might want to make that negative 158 divided by the divisor, x squared minus 4. And I might have skipped a little bit of a step. How did I know that I was done? This is a constant, has a 0 degree. This is a quadratic polynomial, degree 2. So the degree on the outside is bigger than the degree on the inside. We stop. So 3x minus 2 minus 158 over the divisor, x squared minus 4, is the final answer for this particular problem. And that's basically going to be it for division. So there will be homework problems over those. It's good to practice this over and over and over again because we're going to see this on our first test.